You're listening to a Pop House Network podcast for developers by developers. Welcome to Java Pop House 97. Hey everyone, I'm back here with my partner in crime, Bob Holland, and we have a special guest today. We're going to cover things on the Scala front, which is another one of the big JVM language, and I'm pretty excited because we're going to go deep dive and you know, I'm going to learn a lot because to be honest, I tend to use Scala just a little bit, but not a lot. And I know that Scala has the huge release that everybody is excited and talking about. So it's going to be a very fun ride. For those who don't know me, I'm Freddie Guime, one of the co-hosts here at the Java Pop House. I'm a speaker, author, a Java champion, Seattle Java User Group co-organizer, and I'm a principal engineer at Expedia. And I'm here with Bob.
Hey everybody, Bob Paulin, independent consultant from Chicago, Apache Software Foundation member, Java champion, CJUG board chair, and speaker, and excited to dive into Scala today, Scala 3.
Contractor at large. And we have our special guest who's the end-all be-all for Scala. I think number 2 is set from the creator that knows everything about Scala, Dean Wampler.
Hey guys, it's great to be here. Thanks for hyping my Scala skills, maybe too much, but I've been using Scala since 2007 or so. Just finished the 3rd edition of Programming Scala for O'Reilly because of Scala 3, which we'll talk about. I've been doing stuff for a long time, most recently in the data science realm or more data engineering, using Scala, Java, and also a lot of Python these days.
It's kind of funny, Dean. So I remember one of the first talks I went to downtown Chicago was you were speaking at the Loyola for the ACM on polyglot programming, going through a very interesting example of what was it, Emacs, and how you have the scripting language and then the kind of the C language underneath and the value of it. So I still remember that talk, and it's excited to have you on the show talking about, of course, languages.
Well, thanks a lot. I have to be honest, part of the reason I got interested in that subject was I felt that people were using Java too much for everything at the time, when they should be mixing in scripting languages or tools. We've kind of gotten past that a little bit, but even today, you see, if you look at I mentioned data science, all the big data tools that are in Python, it's just a veneer on top of this massive wad of C and C++ code. So it's something we've done forever and will continue to do.
Yeah. Now the architectures kind of continue to evolve, and it's always nice to have I think the reason why maybe it's gotten a little bit away. Hey, I can use Java Java has actually gotten a little better at scripting recently. Yeah. With just being able to do things quickly with Lambda functions, and honestly, Java has been learning and influenced by other languages like Scala, and picking up some of the conventions that has worked for that language has been kind of going back into it now. And we'll probably end up seeing more of that just with the, some of the parameter, the type systems and the switch statements with types. I think, there's still a lot to learn from some of the other languages like Scala out there.
I'm excited to see that particular feature show up in Java. That's one of my favorites in Scala, pattern matching and decomposition of stuff.
Yeah. And you know what I'll do is before we dive in, I wanted to thank our sponsors, Datadog. Today's show is sponsored by Datadog, a monitoring and analytic platform that integrates with over 450 technologies, including AWS services, Docker, and Kubernetes. Datadog's platform brings together metrics, traces, and logs in one place, so you can get full visibility into your environment and improve your application performance. With machine learning-based alerts, customizable dashboards, and distributed tracing, Datadog makes it easy to unify disparate data sources so you can troubleshoot faster. Start your free Datadog trial today. Listeners of this podcast will receive a free t-shirt once you install the agent and create one dashboard. Visit javapophouse.com/Datadog to get started. And again, the URL is javapophouse.com/Datadog. They keep the microphones on and the cameras rolling. So we thank them for sponsoring this podcast.
And the beer flowing.
Yeah, and the huge staff you guys have working for you.
Oh, yes. Labor of love.
Thanks, Datadog. Appreciate it. Yeah.
Yeah. All right. So the big news, I guess, is that there's a new version of Scala, right? Mm-hmm. Scala 3. What can you tell us about it? What is exciting? What are the interesting features that you think are going to be, and are the game changer, or this is more like a Java 7 to Java, or a Java 6 to Java 7 type of thing? So
yeah, that's a pretty big step up. It really started quite a while ago with Martin Odersky looked at the type system in Scala, learned about other people's type systems and realized there were a lot of sort of big flaws that could be fixed to make it more robust, more flexible. I mean, it has a reputation already, especially among Java developers, as being advanced. And sometimes it's a bad word. Sometimes it's a good word, I guess. But so that started it. But, as it came to this kind of conclusion here in the first quarter of this year, where they actually released it, they rolled in a bunch of other things, because it's a major release, why not just go ahead and change a lot of things that you wouldn't otherwise? We can come back in a minute to the whole question of backwards compatibility. I think they've actually done a really good job on that front. But, there's a couple of very exciting things about it. One of which was maybe the most controversial, the type system everyone seems happy with, but they actually introduced a new syntax, an optional syntax, which removes braces, and it looks a lot more like Python. And I think part of the reason was to appeal to Python developers, to appeal to people learning languages that like the concision of Python. I was kind of opposed to it at first because, it's yet another way to do things. And sometimes people think Scala has too many ways to do things, fairly or unfairly. And this is going to be true, but actually I really love this syntax now that I've gotten used to it. It just makes things that much more concise and nice to program.
So they're also appealing to COBOL developers, right? Is that also what they're going for there?
Haskell people, they use indentation too. So I guess it's
so the indentation, just like Python, indentation is what's going to tell you if this belongs in a code block or not.
Exactly. Yep, that's right. It is optional, and you can mix and match, which I wouldn't do, but yeah. So that's one of the cool things. But a lot of other things that they've gone back and fixed. You may have heard of the implicit system, which is a way of doing like conversions to make it appear that methods exist on a type that actually were added later. And, doing things like passing arguments, like let's say a transaction, and I want to just pass the, database connection through without having to actually explicitly put it in code. They rework that a lot to try to get rid of some of the warts and make it a little bit more obvious how to do things instead of learning tricks of the trade. So things like that are maybe the other biggest change.
It's almost like removing the hacks, really.
Yeah.
So why don't we dive into some of the braces, the syntax? I know some of the things that I was looking at and questions I had right off the bat was, okay, well, does this solve tabs versus spaces, or do I still have options there?
Yeah, it's you have to be consistent. That's definitely a disadvantage, like you would for Python. It's just, and of course the editors will handle this for us. But whereas white space didn't matter with braces, it does matter now more. So
yeah. And then they introduced a new keyword too. So they added the end statement. If you want to be it's for being explicit about it. But I'm trying to remember, there's also cases where you may really, really want to use it other than just readability.
Yeah, that's an optional one. If you have like a really long type or method, then you could put end method name, end type name, or end if, end while, that kind of stuff, just to mark for legibility, where it actually ends. I haven't found it that essential in the code I've written so far because I just strive to keep things small. Yeah. But that is an option for that purpose.
All right. Yeah. So I think that those were the only two big things I saw. I knew that there are some rules, but I think if you tend to follow most of your kind of language rules, when you don't have braces, it tends to do what you expect it to do. And there's also a way to turn it off, right? So there's the NoIndent.
That's right. Yeah, you can. Here's getting to the point of transitioning code bases, that you can certainly use several flags to either prohibit the new features or enforce the new styles. And they even have some flags that you can use where it'll attempt to rewrite your code, like removing braces and so forth, if you want to do like a wholesale transition. So they are trying very hard to break this reputation of having breaking releases. In fact, actually, the standard library is basically the 2.13 library, which was the last release in the 2 series, with some extensions. So that and they've even made it possible to compile and mix and match with both versions, whether you're going up or down, which is pretty convenient for transitioning over.
Okay, so a lot more focus on backwards compatibility. Go ahead, Freddie. Sorry.
Yeah, I was gonna say so if you decided to do to use Indent, right, and then you import or has a library, right? Like you bring it the library in, so say for Maven as part of a Java project, and this library is still using braces. Is there's questions in my mind because syntax changes are weird, right? You have 2 ways of representing it. What will happen if I decompile that, right? If I have sort of a braced inclusive library, and I have an indent only project, and I try to look at that, would it know is this an artifact of I'm just looking at the bytecode and I know how to reconstruct this on an indent only type of view, or is it more of these weird questions
Yeah. Well, of course, the syntax is just on the surface, so the bytecode. I don't even know if they remember in the bytecode, with metadata, which style it was. That would be one way to get around this. But yeah, if you use a decompiler, then you'll probably see whatever the decompiler supports, including just using Java P, I guess it is. You'll see Java-esque syntax, which is kind of interesting to look at sometimes. Let me mention a couple of other things that I think will be interesting for a Java crowd around object orientation. Mm-hmm. One of the things I think they've done well in Scala is think about when do you want to freeze a type hierarchy versus allow it to be extended. For example, now we have the optional type in Java, and there it's either going to be I've got something or I don't, and there should not be any other subclass of that, right? Scala's always supported that with the so-called sealed hierarchy, where you can only define all of the subtypes in the same file. But now there's even some new features where you could say, I've declared, actually they've adopted the strategy that if you have a fully concrete type, you've defined all the methods for a class or whatever, that you cannot automatically subclass it unless you explicitly declare it to be open for subclassing, which I think is actually really good for kind of preventing. A personal pet peeve of mine is that you should never override a concrete method, for example, because it's actually hard to know what to do with the super class parent or a method. And this actually forces you to think about what you're going to do. And it turns out what's cool about it, you can actually override it with certain ways. And the way that I would override it a lot would be, I want to write a test double where I'm going to override that call to actually do the database query and put in a stub. In my tests, I'll have no trouble doing that. But in regular production code, I've basically locked it down so that nobody can subclass it because I know what I'm doing or whatever. So things like that, I think, are interesting changes to kind of make object orientation a little bit more, principled, let's say.
Now, is this equivalent to the final keyword for classes in Java?
Yeah, you still have final. And what's different about the two is final is final is final. I could not do that hack that I just mentioned of, a subclass override if something's declared final. But this is a mechanism that isn't actually completely final, I guess, if we can put it that way. But they're sort of complementary in that respect.
Mm.
So as a library developer, I guess you're saying the kind of having the sealed type as the default. So they've kind of flipped how the default works, whereas most of the time extension is allowed. Without doing anything. Now you have to basically open it. I mean, that almost rips off of some of the things in the module system, even though that's kind of a different use case. But you're saying don't extend me by default versus, hey, do whatever you want with this this implementation class.
Yeah, I think it'll be a good example of how a constraint will help improve design overall. Because if you think about, well, I'm creating a concrete class here, I'm declaring it, but I'm now freezing out subclassing for my users. Maybe I should actually change it a little bit, like pass in some dependency that can do changing of the behavior in a more controlled fashion. So I think that it'll actually be a good thing. You're giving up a little bit of flexibility, but you're actually gaining, I think, a little bit of control in a good way.
Yeah, I think you're encouraging more like work by composition. Like I'm going to pass in another concrete that has a behavior that I want, and this is slotted into the class. It means probably a little bit more design up front in order to get it there versus saying, hey, if I don't like it, I'm just going to overwrite it. But I think, and I don't know if this also plays into some of the other new things with the type system, like with union types, where it's like, well, okay, I'm not going to extend the class, but maybe I'm going to take this other class that I have and I'm just going to mush it together.
Like union, like SQL union?
It's kind of like discriminated unions that we've had in languages like C, where the way it usually worked in like the C world is you'd have one little flag in your struct that would say, this is actually a TCP packet, this is a UDP packet, and then you would know how to interpret the rest of the bits. Is kind of an analog I like to use. So yeah, there'll be a way to say, I'm going to but I'll give you a great example. I'm either going to return a new consumer object, or I'm going to return an error. And so it's a way of actually very concisely declaring situations where you might have a normal path of return, and then you want to return an error as opposed to throwing an exception. There's already been a type for that kind of, it was repurposed for that called either, which, you had an A and a B, but now it's just a little bit more flexible. There are some criticisms that have popped up about union types that I'm not sure I fully understand, but it does give you a little bit of flexibility when you have these, it can either go one or two ways or one of three ways, and I'm going to, but they're not related by a common super type in the usual sense.
Mm-hmm. No, I can see that, because that is sort of like the bane of any programming language, is how do you handle exceptional cases and error conditions, right? So that is an interesting case. So was that essentially like the spirit was trying to figure out a way for instead of coupling, because that is what happens. You couple the error as part of your response message, and that is in there. And usually what happens is either you fill one or you fill the other, right? It's actually, the more you think about it, just like you said, there's an enum or a bit on the top that says like, oh, this was successful. No, this wasn't. And there's the big if statements that you do. If successful, then continue. Else, look at the error, retro it back, or put it on another response object.
So actually, you brought up a good point. How do you handle that thing when it comes back? And the sort of canonical way is you use this pattern matching we were just describing. You know what you expected. So you either, is it this, or is it this? And then do the handling. And sort of the analog too is the intersection types, which are more like what we're used to, where I might have consumer object with transactions with closable, those kind of mix-ins that we can do in Java as well as Scala. Those are now modeled as intersections. And the way to think of it is, if I just have a consumer type, all the possible instances, form like this big ball, and then a smaller bit would be the ones that also happen to be a subtype of, transactions or something. And so you think about set semantics of unions and intersections, and that was deliberate to make it more robust, the types checking to just follow set theory semantics.
Huh. It's so crazy, because I usually don't think it that way.
Well, yeah, you look at the examples, just, I'm looking at the kind of the website of intersection types, the resettable and then growable. And, you do your and sign between them. And then you're basically given a variable that I can call either method on. So you've basically extended your classes as you're going along. and giving them additional behaviors, but you don't have the class hierarchy that you'd have with, when you're extending, as you would do with a Java class.
Yeah, really, it kind of boils down to the only actual difference is Scala lets you not have to declare a type that does that mixing and then use the type. You can kind of do it on the fly. So that's really kind of the only practical difference, I think, and, unless you get down to technicalities.
Yeah. That's what I think it is, right? Like the mixins essentially is dynamic interfacing. It's sort of like injected into that object you have, and it sort of acquires those properties.
Two great things that Java added since I got into Scala. One was the obvious one, Lambdas, which just cut out a lot of boilerplate code. But the other one was adding, I think they call them default method implementations on interfaces, which let you do more true mix-in type composition. Java's, I think, been good to kind of start bringing in stuff that actually is pretty useful from other languages.
Yeah, you get almost that multiple inheritance type, the thing that, you would have with multiple inheritance, but without a lot of the terrible things that you get with multiple inheritance.
Yeah.
When I think of traits and things in Scala, I mean, the Java equivalent that usually pops into my head is, it's kind of what they stole with default methods, but kind of you have more things you can do with it in Scala. Java just kind of took the narrow fraction that it thought it needed to get things done for collections.
Yeah. And then like I always think like default methods, like if you have the ability to think about it through from the beginning, usually there's less need for them. But in terms of evolutionary APIs, it was the right move just because of the way that this history of like, how do I extend a collection without breaking what was there before? And that is essentially, you have a library that requires, you upgrade the library and you have code that still requires to work as the interface that has not changed. And that's when the default methods, sort of like went in and swooped in to save the day. This is interesting because what is making it is a very succinct way of you handling like these objects that are coming in such a way that you're doing, wow, that is so cool. In such a because there's like Java will be very verbose. I think you can do exactly the same thing with resettable and growable in Java, but it will require you to do sort of like a cast to resettable to be able to reset it, and then a cast to growable to be able to then add. Here you just do it like that. That's fun.
All right. So why don't we switch gears a little bit? So you started alluding a little bit at the very beginning to some of the contextual abstractions piece that's very new. Which is, it's something that they were improving on from, I think it was called Implicits is what they used to be called, or what was in the prior versions. Why don't we talk a little bit about that? Because, that your example you gave at the beginning was, hey, I can have a database connection defined somewhere and it's going to go into this method, but I didn't actually type out passing into the method. How does that work? That sounds kind of amazing.
Yeah. There's probably two fundamental categories of how this one mechanism called implicits was used. And you just mentioned one, which was, the idea was, if I have like this API where I'm constantly passing some context object all the time, or maybe more than one, to make the code cleaner, I could declare that some instance of that object as an implicit value, so to speak, and then mark the method signature so that if I don't explicitly give you a value, then use whatever implicit is in scope so that it makes the code a little bit more concise. I actually think that it's way overused, that particular use of implicits, because it kind of becomes magical. Like you don't, the IDEs help, but you don't necessarily know everything that's going on when you've got implicits that maybe you imported without realizing it, and now they're flowing through your code and you don't actually realize it's happening. So I actually encourage people to use them in a very constrained way. But they have improved the syntax a little bit to make it like, for example, you can now you can do like import star, the equivalent, you can do in Java, but by default, it will not import implicits unless you specifically tell it to. So things like that give you more control. And then so the way that you actually pass arguments explicitly, it eliminates a few of the ambiguities that happened sometimes with the old way. I think the more interesting case is really sort of the other kind of category of implicits, which was things like, this method takes a dollar object, but I want to be able to use floating point literals because that's convenient, right? And then I want it to magically convert to a dollar when it actually calls that method. Those were always called implicit conversions if you had something in scope that knew how to do that conversion. And the compiler would say, oh, this method takes a dollar instance, but you gave me a float. Oh, but I see in scope there's this conversion that can return a dollar for me, or dollars, whatever's the right name. And then I'll just pass it. That used to be used for all kinds of things. The other big use was, I want to have a toJSON object on my hierarchy of like customer types, but I don't want to have to edit the library to add that method. So I'd like to be able to extend all of those types so that I can just say, this customer .toJSON, and it'll just magically work. So the way you used to do that was this sort of idiomatic trick of make something an implicit conversion that has that method. The compiler says, oh, I see that conversion will give me the method I need. And then it would do it for you. They've now done what C# has done for a long time in other languages. There's this notion of extension methods where you just say, extension of this type. Here's a new method. Here's the implementation. You can also do it abstractly with traits, which is the analog of interfaces. So I think the way they described it is trying to get away from a mechanism that you have to know how to use in idiomatic weird ways to actually idioms in the language that more explicitly and kind of obviously state what you're trying to do. And it's less about this kind of crazy mechanism. I don't know if all that made sense, but
no. I was just going through some of that, yesterday as I was looking at it and saying, so you're basically when you're doing that, you're defining this using statement in the signature, right? Where that using statement is going to have, in the simplest case, without the conversions and things, you're going to define a type, so it knows what kind of type it's looking for, and then just to completely make it simple, it's looking for something in scope. So if there's a loop or a for or an if statement or something, it's looking for something in that localized scope. Or can it go outside too? Like if it's defined, say, in the main method and we're kind of down the stack, is it going to?
It's completely scopable. So you could literally just have something inside like you said, an if statement or a function or a method block that is the implicit only visible in that scope.
Yep. And your statement about, some of the ambiguity, like I could have two objects of that same type that have been defined in that scope. Oh, how do I know which one I pick? And I think one of the things I was looking at, was it the given clauses where I can kind of say, hey, if I have an implicit argument, this is the one I want you to use. So I can just kind of tag it and say, if we're going to do this, use this one.
Yeah, exactly. So givens are the new way of declaring something that you want to use in an implicit context. There's still rules about if it's completely ambiguous which to choose, the compiler will treat it as an error. But it's also scope. So something that's more closer in scope will take precedence over something outside of that scope.
Okay, good.
Again, when you're getting to those kind of problems, you should step back and say, am I getting carried away with this crazy stuff?
Yeah. What am I really trying to do here?
Nobody's going to be able to read this and maintain it, right?
Exactly.
When I leave.
But the key thing you said, so if there is ambiguity, a lot of times the compiler is going to throw an error to at least bring it to your attention if you didn't already notice it.
Yeah. That's actually something else I think they've improved a lot. The error messages tend to be a lot more descriptive and useful now than they were in the past.
Oh,
which is good. Always a hard thing to do in a language.
Yeah. And it looks like they did do, some things with the compiler. I don't know how deep you've gone into that. I know I've just was just reading through some of the notes to see that there were things that were built out compiler wise. What's this? What's this Dotty thing? Do you know anything about that? That seems to have something to do with. backwards compatibility as well.
That was kind of the project name before they finished and renamed it Scala 3. And it was based, the name came from this new type theory called dependent object typing, which is another crazy thing in the type system. You can say things like, you can do type arithmetic, like I can declare, I can say like value I of type 1 + 1, and the only allowed instance is 2. So, or I can just say that, the type is 1, and hence the only allowed value is 1. Mm-hmm. That sounds kind of crazy. Like how is that useful? It turns out when you go beyond the simple examples like that, it kind of sets the stage for writing much more robust methods where, and I'll give you an example, it's my favorite. I could have a collection class where if I add an element to the collection, at the type system, I can enforce that the number of elements, the n, if you will, has to go up by 1 or has to drop by 1 if I remove it. So it gives you a little bit more rigor about the overall state of things. Put another way, there's a lot of ways in which type systems can't, catch all possible errors. That we can declare a type signature of a method and then do something completely crazy different inside, as long as we return, an object that looks right. Well, this dependent typing is just sort of, kind of covering the ground a little bit more about disallowing things that you should really prevent from being legal. It's kind of advanced stuff, and it's not clear yet how pragmatic it's going to be. But I'm kind of excited about it because of these kinds of bits of rigor that can add to our designs.
Does that go down some of the path of some of that machine verifiable code correctness, where it's like if I'm enforcing it at that level, I can almost like mathematically prove that my code is bulletproof because you're not allowed to go out of bounds. I mean, I know that's something that's a little bit. I don't know anybody that's doing it. Maybe NASA's doing it when you're sending people into space. It's important, but
wasn't that like a study where it is proven that code cannot it's what is like unverifiable for completeness? I sort of remember doing that. Somebody this is like a paper that was like back in the 1900s, and it was old. It was just a mathematical construct that you cannot have that are verifiable.
Yeah, this is on the edge of my understanding. But for example, I think open recursion, just allowing arbitrary recursion, is unsound. Is kind of the term they use. So languages that try to really nail down everything with the type system actually put very strong constraints on things like recursion, for example. And I can't really say more than that, but if you think about all the problems we deal with bugs, and of course all the famous failures that have happened, with software and it causing death or loss of, catastrophic loss, I think it's still something we have to strive for. Is how can we both make things approachable to mere mortals like you and me, but also kind of really squeeze out all possible bugs as early as possible in code. So that's why I keep hoping that stuff like this will push us in that direction.
No, and that was interesting because still remember Josh Block had a talk and the way that he said he's one of the big reasons why Java changes is he said to try to give less room for little bugs to hide. Mm-hmm. That was always one of his guiding principles. And I think we're talking about value types in Java, where essentially you can you give away some freedoms. There's you cannot sort of there's a specific declarative syntax. There's the getters you cannot modify. The sorters you can modify. This is just the way it is. But because you give those degrees of freedom, then we can make certain specific contracts, just done, like the equals hash code and all these things, right? So and that was one of I think I've seen a lot of that, sort of resonate here on the changes, where it is not necessarily about the new features, but a way for it to be very explicit in what is being declared and how is it supposed to be consumed. Without removing the liberty. You can still do whatever you want, but now there's sort of this shell that says this is how you can protect yourself from an unknown decision that happened way beyond what you were working on. So
yeah. I think a good example of this is, which Josh talks about in his books, is properly implementing equals and hash code. It's actually hard to do it right. I like the fact that Scala case classes, they just automatically generate those for you. I don't know if Java is getting to that point or not, but I think that would actually just one of those things that would help eliminate a lot of bugs, I think.
Yeah, no, we use hacks like we use Lombok. I guess we will use Lombok until 17, and then Java 17 has some interesting issues with Lombok.
Cool.
But there are implicit for like value types, like so those actually work like the way we think it should work. But yeah, so I know like I wanted to like get us sometime like our crowd is mostly a Java crowd, right? Like
yeah.
I wish they they get to know. We sort of like see now that essentially Scala tree is a place where I'll say like you're saying we're fixing certain things, we're making other things easier, we're making other things more explicit so you don't make mistakes. So it might be like a good version for somebody who maybe been burned before or never tried it before, to say like, oh, is it time to take a look at Scala again? And for those like, I guess the question will be like, when do you think like, or what will be an appropriate time? You have a Java developer that is working, his exposure to Scala was, like unit test, right? and then, but there might be a case where actually this Scala makes sense, right? And how would you guide them towards making that decision? When is it time to jump in?
Yeah, that's a good question. I think the language is pretty solid as far as like, safety and actually moving to it, if that were a question people had. One thing I wouldn't do necessarily is write a Scala library that you're going to call from Java, because you kind of have to know how to do that right. It's easier to go the other way, and it's not impossible. Actually, you mentioned play when we were talking before we started. Play is written in Scala, but it's most commonly used in Java. The same is true for Akka. So I wouldn't recommend that approach. But if you have some small utility, maybe it's going to run as a separate microservice, or Kubernetes pod or whatever these days, then it might be a good thing to try to consider writing it in, especially if it's reasonably standalone. Try it in Scala, see how it works. If the experiment fails, or you just decide that, for our organization, we're not really ready to adopt a mixed language environment, or blah, 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 then it's fine to step back. I certainly respect people that have to weigh those real world pragmatic issues.
Mm-hmm. And now, like, but one of the things I always hear is like in the data science world, Scala is very well adopted, right? Like, so what is the attractiveness? Like, if I have to do something data science, right? Like what would you say? Like, why does Scala, for example, shines next to Python? Like, or why would I choose Scala over Python? Maybe that'll be the question.
Yeah. That's been an interesting story arc, I have to say. So, about 5 or 6, maybe longer, almost 10 years ago, when Spark really got popular. Spark was written in Scala, and when it first came out, this was before Java had Lambdas. And it was really quite evident that if you compared a Scala program for Spark and a Java program, the Java program was just unnaturally verbose, and the Scala program tended to be very elegant. So that got a lot of people excited about trying to use Scala for these sort of data pipelines, or engineering-oriented hacking on data. And it turns out Kafka is also written mostly in Scala. So that sort of drove a lot of interest. Certainly, 5 or so years ago when I wrote the last edition of the book. To be quite frank, though, that industry has kind of evolved to be more focused on data science, like doing machine learning, doing deep learning with neural networks. And by far, that whole space is dominated by Python, with some R, which you may have heard of as a statistician's language. And then there's this sort of new kid on the block called Julia, but it's really a Python world. So I have to say, what I see is a lot of the engineers who are still responsible for getting stuff in production might still be using a JVM ecosystem. That maybe the need to use Scala in the way I just described isn't as compelling, because again, Java has gotten a lot better over the last decade. So a lot of teams are just saying, we'll just write our Java, we'll do our JVM infrastructure in Java. I'd rather they use Scala, but that's their call. But then, the data scientists are mostly using Python. There is actually a cool library that this brilliant grad student at Berkeley has written. I think it's called PyScala or something. That's actually specifically makes it easy to write Scala code that's calling into Python libraries. But really realistic. That's for somebody like me. That's not for somebody who's really doing enterprise development at this stage. So just to make this short, I guess Scala is still very interesting in a lot of ways for these problems. I still love the concision of it. But the thing that was kind of driving the enthusiasm in the early days of Spark is transitioned more to Python at this point.
That makes sense. But and the kind of the flip side of it, maybe not the flip side, but maybe a tangential question on that is we also have a lot of enterprise Java listeners that maybe are not doing anything with data science. Is there anything compelling in Scala 3 for maybe somebody that's building microservices and web services for a company that is not in the data science realm?
Yeah, that's a really good question. I think you'd still have to step back and say, am I ready to make this transition? And the things I'm about to say, do they actually justify the work? I alluded to earlier some of the features that make Scala a nicer object-oriented language. If you want a little bit more precision in your environment about how people declare types and type hierarchies, that's appealing. You mentioned, I think, Freddie, value types, which I think are coming in Java 17, if I'm not mistaken. Is that right? Which is a long time coming. Scala has some similar mechanisms that let you declare stuff as if they're regular types with all the object-oriented goodness, but they actually compile to things like doubles, floats, or eliminate the wrapper around the types. If you're wrapping a string to make it look more like a zip code or something, you can eliminate the wrapper around the string, that kind of stuff. So there are some performance advantages there. To be honest, I think if you're really comfortable with Java and you are keeping up with what's going on in the Java ecosystem, I think you're still in great shape. But if you really are maybe wanting to get more into functional programming and exploit some of these other object-oriented features as well, then it might be worth investigating.
No, and that's true because one of the things is Java is a general purpose tool, right? So you can write it imperatively, you can write it sort of reactively now. And functional programming, it's not that it's impossible to do in Java. You definitely can. It's just that it's is a disciplined path that you have to take. I guess the advantage is that Scala that just comes with the package. It's functional. It's thinking as functional programming first. And then you can derive from that, but it's the other way around. It's if you start in Scala, you get FP, and functional programming it's a good skill set to learn because it makes you think differently about everything else and how idempotent methods actually help you not have any bugs, which is it's super fun.
Yeah, exactly. Yeah.
Let's talk about the flip side of that, though, too. So there's also the developer that is already using Scala, and maybe they're on Scala 2. What has been your kind of take on, hey, what's the upgrade pain? Are there things that maybe they've removed? Because I know they've deprecated a lot of stuff, too, that you think that people might miss or at least might make them have to change their code. What are your kind of thoughts on that?
Yeah, most of there were a bunch of things they deprecated and either actually removed or it specifically said they're deprecated and will be removed in a future release. Part of the way they wanted to address that issue was by providing these facilities that the compiler could help you rewrite your code, either with the new indentation-oriented syntax, or just to flag things that are now deprecated and give you a chance to remove them. Most of the stuff that was removed or deprecated actually wasn't used that much. And even the implicit mechanism I just described, that you're going to be able to use both in tandem, and they do interoperate reasonably well. for quite a while, because it'll take a while for people. I do think there's enough that's really great about the update to the language that people should have a plan. And one of the first things you should do is get to the latest release of Scala 2.13. The reason for that is that actually two reasons. One is that's the same library, especially the collections, that you'll be using in Scala 3. So fix any issues with that upgrade. The other bit being that I mentioned earlier, that you can now actually compile and use libraries interchangeably between the Scala 3 and Scala 2.13. So that's a good thing to be in a position to do if you really have to move. Like at Domino, where I work, Domino Data Lab, we have a lot of software written in Scala, and for us to move it to 3, will have to be an incremental process where we move some of our Git repos first, and then gradually bring others up as well. So that'll be an important ability for us.
Okay, so probably it's not going to be a big bang project for our Scala listeners. It's an incremental thing. You probably start at the top of your dependency tree and work your way down.
Pretty much, yeah. That should work pretty well.
Okay. Yeah. No, I mean, I was looking at some of the things dropped, the one that surprised me, and not because I use it so much. It's just the very first control statement I learned how to use was a do while, and they're dropping the do while. So I was just kind of surprised to see it. But when I think about how many times have I actually used that, like professionally, I don't think I'm going to miss that one.
Yeah, I had the same reaction. I never used it either, but I thought, doesn't every language have to have this?
I feel like that's almost just you're peer pressured into having to do well.
Right. Yeah, a do. Maybe I'll add a doo-wop at the end or something.
Yeah.
I wonder. I'm trying to think like it almost feels like it's like you have to have that first. Like the things I remember using do while for is like reading off the wire, and you have to have a packet. Like
there's always a first.
There's always you will always have a first. That is sort of like the part that I remember using a do while.
Yeah.
Oh, that's funny.
Let me make one other comment, if I may, about Java versus Scala. I think the new syntax is actually an indication that the Scala community recognizes that we're probably not going to convince that many more Java developers to come over. The people who wanted to come over probably mostly have already. And Java, as we've said, it keeps getting better and filling in some gaps in the two. So I think in a way, the Scala community is kind of positioning itself to be more, here's a mainstream functional language with object orientation. So if you're coming from any other language environment and you want to be on the JVM, or you want the performance and other things, then it's trying to be more broadly appealing in that regard without necessarily being specifically targeted. And, you can actually compile to JavaScript now and even natively. So it's kind of expanding a little bit in that regard.
Yeah, that's actually one of the more interesting things. We had Chris Thillinger into Chicago a few years back talking about GraalVM and the usage of that with Scala at Twitter. And, if you're just writing in Java, that, the performance gains are, it's kind of even, maybe a little degradation. But when you use it with the dynamic functional language like Scala, like they got some serious gains out of using the GraalVM.
Interesting. That is interesting.
Now, is it like I actually how hard is it to get to run? I don't know if you have done this. How hard is it to get a Scala program to run in Graal? Like
native compilation, or you mean like the VM? Okay, there.
That's a good question. So they call it Scala Native is the project. It's a little behind and less mature than the Java and JavaScript. And you have to do some code porting because you don't have the same library that you have, like things like strengs and stuff. I haven't tried it myself. It's been one of those to-do items on my long list of bucket items. It'll probably be a bucket list at the end. I'll have to do it last when I'm dying. I'll
call Bob and Freddie just to like.
I did it.
You guys, get me on. Oh no, too late.
Oh my gosh! No, but I think it's probably like different concerns, right? Like I think in Scala you are more worried about like the composition of your program, because again, like I'm thinking like when I do a regular CRUD application, with a create update, it's not that big of a deal if it's small. But this allows me to almost like not quite put like a meta type of like fence on any of the structures that I do on the program that I'm writing. So it feels that the Scala's biggest concern is like making sure that you don't, that you have a solid sort of like guardrail for, those projects that you're working on. So, again, Java allows you to do anything. Scala is almost like saying like, this is the better way. You can still do anything, but I'm going to guide you first to here and then start from there.
Yeah. Yeah.
So in terms of and I guess like for the upgrade path, like because I think that happened to Java too. Like for us, the big jump was from 8 to 9, where 9 was broke everything for a while, and then after 9, it's sort of like the other ones have been a little bit less painful. Actually, they've been mostly painless going after 9. So is the expectation is once you are in 3.0, is it you're saying that there is now more concern on the backwards compatibility, or is it still like because I think that one of the things that I do envy about the Scala ecosystem is like if you folks decide this is wrong, we will remove it and we will change the syntax. Like Java is very like, we can't touch anything. You're gonna do this little like kludge to get us by.
Well, the last statement you forgot is, and you will change your code because you have to, and it won't compile if you don't.
Good or bad. Yeah, like Java developers, because we are not as smart as the Scala developers. We don't want to change code. It's like, oh, it's working, leave it there, right? So I think that they did like a study, like somebody was saying, like you can still run Java 1.0 bytecode in 17 almost like as is.
It's amazing.
But yeah, so for the Scala, like for in 3.0 is the idea that now. Is it a point where Odersky said, okay, I'm getting happy where we are. We're not going to break anything back. We're just going to keep just adding, or is it still like, or do you think still there's going to be evolution where we say like, oh, there was a question mark on this decision, and now we decided that it's not worth for us to keep doing that.
Yeah, so here's what I think will happen. There were a few things that were put in last minute that they may have to refine because. What is an example? There's a new type called matchable that's the top of the Scala hierarchy is any. And then underneath any are the value types that you all know from Java, like double and so forth. And then the reference types, which are string and person and all that. They've added another one up there called matchable, and it's designed to fix a hole where you could actually have something that's supposed to be an immutable wrapper around a collection actually get the mutable collection pulled out and then modified. Again, a little hole that lets you break something. This was something that actually makes a lot of sense. It turns out I actually tripped over a whole lot of side effects that it caused because I was working with these incremental releases. I mentioned this as an example, not to get into too much detail, that there may be some things they tweak. There will be some things they've said, look, we're going to transition away from these Scala 2 features, but not take them away right now because, it'll break everything. So there'll probably be a year or two where people are, removing stuff who've been conservative and incrementally just pulling them out when they have to. But I think it's not going to be that terrible. Like you say, the community kind of has embraced the idea that you do have to change code to keep it up to date, for better or worse. There's always trade-offs here. Actually, I don't know if the listeners have ever heard Brian Getz talk about like the design of things like Lambdas and trying to preserve backwards compatibility and finessing around. He's really brilliant, and his talks are just very insightful and enlightening about this. So, yeah.
We had him speak actually in Chicago about some of those topics with Lambda. And I think I heard that talk initially at Java 1 one year when he was talking about like why they did Lambdas the way they did. And it doesn't work how you expect, but here's why.
Yes.
Yeah. They're non-anonymous inner classes. Which was, I thought it was like at the very beginning, it's a shortcut for anonymous inner classes. That's what it is.
Right. Yeah, for a while, Scala used those kind of anonymous classes, and then when finally transitioned to use the Lambda mechanism, so that you can actually interchange Java and Scala Lambdas if you're really mixing code.
Now, just back a little bit to the topic of upgrades. So if I'm looking to move to Scala 3 and I have libraries that maybe haven't been written in 3, I know you said a little bit about, hey, you can still, if it's written in 2.13, you should still be able to use it. Are the library developers going to have to release something built on 3 before I can use it? Or how does that work in the Scala world?
Yeah, it's supposed to work. If it's written in 2.13, and it might actually be a later, I think it's just any 2.13, you should be able to link it just fine in a Scala 3 code base.
Okay.
I know I've heard there have been some warts that library maintainers have run into about this. So the normal path would be just make a Scala 3 binary version. But if you don't have access to that, then you can use a 2.13. And correspondingly, if you want to use a Scala 3 library, with maybe the exception of some of the new, they redid the entire macro system. Most libraries will actually work in Scala 2.13 that were compiled with Scala 3. So yeah, it won't be a perfect, seamless transition, but hopefully not too painful.
Now, just as an impression, what kind of warts do you expect? Would they be compiler errors, or are these like runtime things? And if you're going to do that, you better test pretty heavily.
I think mostly it'll be compiler errors.
Okay.
You import something and it doesn't quite type check correctly the way it should. It's pretty good about catching. In fact, it's kind of, you guys alluded to this earlier, that sometimes when you run into these things, or, I can't find a library version, I need this point really. Sometimes it comes down to just some fine details that are actually in the bytecode that it's just being very conservative about.
Okay, no, that makes sense. And that gives a lot of hope that, if it's not going to work, you're going to know up front. You're not going to push your code to prod and then discover it doesn't work.
One of the interesting things they introduced, they backported it to 2.13, but introduced it in Scala 3 is this intermediate representation that's kind of sits between bytecode and source code. And what's kind of cool about that is it makes it a lot easier to do this interop across versions, and probably going forward, it'll be much simpler to deal with versioning. But it also, I think, provides a nice way to inject code analysis tools that don't have to be able to parse source code. They can just look at this well-structured intermediate representation.
Wow.
So I don't know if that'll affect Java eventually or not, but it seems like it's a good direction in general for language environments to be going, is make sure there's a clean intermediate representation that people can really instrument well with.
Bytecode for the bytecode.
That's exactly the thought.
It's all turtles all the way down, man.
It's always been turtles.
Oh, it's JavaScript in there somewhere. It's all kinds of JavaScript inside in there somewhere.
Oh gosh. Wow. I mean, this is amazing. Like, I think, it's fun. It makes you, like, again, it's, even if you don't ever had to use it, it's always fun to dive in once just to see what happens, and just the way that you start thinking of changing, like the way. And one of the caveats is, like, you can write Scala as you write Java, but you'll find it hard. The idea is that if you write Scala as Scala intended, suddenly you start seeing like patterns that are not as visible in the Java, because Java usually lets you do everything, but it changes the way you think about programming. And it's always one of those tool sets that you have in the back of your mind about, like, maybe this is what I actually do want immutability and more functional, orthogonal concerns on how I program these things. But Scala 3 seems like a fun way to jump back in the swimming pool instead of just doing my Cucumber and Gatlin. So I'll be revisiting it.
Yeah. One thing I'll mention, I have on my website a concise summary of the Scala 3 changes. If anyone's interested, you can go to polyglotprogramming.com and you'll see a link, or go to the page about my book, and you'll see this one page. I'll send you guys a link if you want to put it.
We'll put it on the show notes.
Yeah.
That's awesome.
Absolutely.
All right. I think those were all the questions I have for Dean. I don't know if you have anything else, Bob.
Yeah, we got through my whole agenda. I'm very impressed with this. Usually we meander, and we were on the ball today.
Dean he's very functional that way.
Yeah, that's right. Dean is a functional agenda.
Like not dysfunctional.
Things going in. They got processed, throw them back out, make sure that we didn't do 1 + 1.
Well, this was great, Dean. I really appreciate having you on the show. Looking forward to hopefully seeing you at some events, once things start to get in person again.
I'm looking forward to it too. I really appreciate you guys inviting me today. It was great to see you, and have a good summer.
All right. And with that, we conclude another episode of Java Clubhouse. Happy programming, everyone. All right. We did it.
All right.